The broadcast is now starting. All attendees are in listen-only mode.
Welcome to Writing an RFQ that delivers the right product at the right price, a webinar presented by IRD Glass and hosted by Photonics Media. My name is Robin Riley and I am the Photonics Media web editor. Our speaker today is Michelle deCastro, National Sales Manager for IRD Glass. Michelle will be speaking today on how to write an RFQ that clearly communicates your business priorities in the areas of pricing, performance, and service. If you have any technical issues during the webinar, please log out and log back in to rejoin. A recording of the webinar will be available on the Photonics Media website shortly after this presentation. We encourage you to ask questions throughout Michelle's presentation. Just type your question in the question box to the right of your screen, and we will answer as many as possible at the end of the session. And with that, I would like to turn the presentation over to our speaker, Michelle deCastro. Welcome, Michelle.
Thank you, Robin, for the introduction, and thank you all for joining us. As Robin said, today we'll be talking about getting the most bang for your buck when requesting quotes for custom glass optics and technical components. Answering these common questions during the RFQ process will enable your custom glass fabricator to present you with faster, more accurate quotes for your project. You'll learn what to include to enable your fabricator to incorporate your business priorities into the quote. This means a quote that optimizes specification, pricing, lead times, application performance, and service to your needs. Sticking with IRD Glass's manufacturing strengths, this talk will focus primarily on flat and machined optics and technical components. There are additional considerations for lenses, freeform optics, and molded or blown glass that will not be covered. A little bit about our company. IRD Glass and Ceramics has been a custom component manufacturer for over 30 years. We process a variety of materials, including most glass types, ceramics, sapphire, and silicon, from multiple material suppliers. As a veteran-owned small business, we've continued to grow steadily through long-term partnerships with our customers, as well as strategic investments into our manufacturing capabilities. For the past few years, IRD Glass has made extensive capital investment and process developments to focus on machining and polishing sapphire windows and sapphire precision components to add to our glass capabilities. We've drawn on our long history of solving some of the most difficult manufacturing challenges in a range of materials, from super hard silicon carbide to soft specialty glasses. Our customers are always pushing the boundaries of what is possible, and so are we. Aside from stock sapphire window offerings, IRD Glass is a 100% custom manufacturer. Every day, we help customers optimize their RFQs and product designs from manufacturability, performance, and cost. Here's an overview of today's talk. These 8 topics should be included in all RFQs whenever possible. Most people remember to include materials, dimensions, usually as a drawing, quality specifications, and coatings in the request. But you'd be surprised how important the rest of these items can be in getting the most bang for your buck in a quote. Details such as assembly, cleaning, and packaging can streamline your manufacturing process. The development stage of the project, volume requirements, and time frame can also affect quotes. And finally, the application, often veiled in secrecy at the detriment of your bottom line. What material is your part going to be made from? Customers usually have a material type chosen already, but full service providers like IRD Glass can help you make a material choice or advise a lower cost or lead time alternative. Material choice is typically driven by a balance of physical properties, cost, and availability. The most common properties for optical applications are optical transmission and index of refraction. But many applications require materials with added strength or hardness, such as for cover windows. The ability to withstand high temperatures or large temperature changes, such as space applications, or various chemical and environmental conditions, such as oil field applications, and some dielectric insulator applications. Knowing why you've chosen a material can help us recommend alternatives or make sure we supply the appropriate material grade. Customers often do not specify the quality grades of their choice material, which can be a problem. For optical transmission applications, this information can be crucial. For example, the very common material fused silica is available in a variety of grades that significantly affect price, optical performance, and overall application performance. Materials are made in a variety of methods, including drawn glass, block glass, or grown crystals. Available sizes may be smaller than needed, or extra processing required if the preferred format is not available. Yields may be an issue. Many custom fabricators keep a stock of the most common glass types and sizes. For materials needing to be ordered from glass melters, lead times could be long and they rarely expedite. Some glasses are only made once every few years, which may mean very limited availability or limited sizes. Some glasses are easier to process than others. Sapphire, being super hard, requires extra processing time or expensive equipment. Some glasses, such as IR blocking blue filter glass, are extremely soft or fog up in humidity. All can affect yields or processing times. Germanium and other IR materials can produce toxic dust and require special contamination measures. In summary, it's good to keep an open mind about material type. Different materials affect pricing in a variety of ways. If it's a new product, provide as much information as you can about why you've chosen the material you have. There's a good possibility that there could be a more cost-effective or quicker material that will do exactly what you need. Here's a list of some of the common materials used for custom flat optics and technical components. From the cheapest commercial grade soda lime glass used in everyday windows to the highest purity fused silica. These materials are made in a variety of formats and sizes. For example, BoreFloat is a high quality float glass. Although not quite optical grade compared to NBK7, it is a suitable material alternative in many optical window applications. Because it's a floated glass, it can be significantly cheaper than NBK7 by minimizing or eliminating the need for lap and polish processing. Filter glass is generally provided from glass makers as unfinished 6-inch square sheets. Considering the format, 2-inch rounds aren't going to be the most cost-effective size for yield in this material, especially in smaller volumes. Crystalline materials such as sapphire and silicon are grown to size, and therefore much more expensive in larger sizes. For window applications using sapphire, you may be better off with multiple small windows rather than one big window. For very thin glass applications, less than a millimeter thick, extra processing is often avoided by using high-quality drawn glass or overflow fusion glass. Glasses are made in specific thicknesses, so the design flexibility to use the standard thickness is often a much better solution for cost and availability. Now that we know what material we're using, we need to know the size and shape. Drawings are the best way to convey this information, even for simple windows. When information is provided as a text list, there is inevitably missing information or confusion. PDFs are a great way for sales teams for initial review and consultation, although SolidWorks and other drawing files are good for more complex parts when discussing with engineering. Length, width, and height are obvious, but don't forget to add tolerances. If a dimension isn't important or is flexible, let your fabricator know. There are a lot of behind-the-scenes cost factors that they can take into account to make a recommendation for you. Parallelism, angular tolerances, and radius of curvature will be important depending on the part. Bevels and/or edge chip specifications are a must. The edges of parts always have chipping, depending on what magnification you use to view them. Even a laser-cut edge has microchipping. It's important to let us know what is acceptable. No chips is pretty much impossible or is going to cost you a lot more than you bargained for. A typical cost-effective chip spec, depending on part size, is less than half a millimeter or can be substituted by a bevel edge spec. If a bevel edge is for safety only, let us know the maximum size. There's no need to overspecify and add cost. Tolerancing and specifications can get creative to optimize manufacturability and minimize cost. For example, we've had hexagons where the sum distance between sides was more important than the individual sides. So we had made the spec accordingly. Maybe for your applications, chips only need to be minimized along one edge. Or maybe it's only the quantity of chips that's of a concern rather than the actual size. These creative specifications can help reduce cost by increasing yields. When it comes to surface quality, things start going awry near the edges of a part. There's chipping, roll-off, coating fixture shadows, etc. It's best to define a clear aperture, which is the area where surface quality specifications apply. A typical clear aperture of 80 to 85% is the most cost-effective, with larger clear apertures adding cost. If the application allows, clear aperture and chip or bevel specifications can be combined. Let your fabricator know which surfaces are important and which can be left to best manufacturing processes. Many applications require flatness control of one or multiple surfaces. For transmission optics, usually the wavefront error is the primary concern, and that's controlled by the flatness of multiple surfaces, the parallelism between them, and the material. It's important to let us know if the part will be used as a transmission optic or reflective optic, or as a non-optical component to better understand the tolerances and specifications. When specifying flatness, it's usually designated as waves using a 632 nanometer reference wavelength. Different wavelengths can be used for testing, so it's important to designate the reference wavelength for your specification. Sometimes flatness is called out in microns instead. For high precision parallelism and flatness, double-side polishing is the preferred manufacturing method. Double-side polishing is a high-volume process, so low-volume runs will not be as cost-effective. Surface quality is also cosmetic and indicated by a scratch dig specification, either the USA mil spec or a global ISO spec. The first number for scratch dig is qualitative and defines the scratch visibility. The second number is quantitative and defines the size of the pits or digs. Because it's qualitative, special comparison targets, such as the picture to the right, are used to determine scratch dig spec. Your fabricator can also compare your quality control procedure with their own to optimize a correlation on the scratch dig. Surface roughness is often not required specification. Specifying scratch dig quality usually yields a suitable surface roughness for most applications. There are some applications, however, such as high-power lasers or precision mirrors, where surface roughness is important and should be specified. For many applications, scratch dig specs are cosmetic and don't affect performance much, other than a slight loss of transmission or increased scatter. Surface quality specs are the most important when surfaces are near the image plane or in high-power applications. When in doubt, the breakdown of quality levels shown here is a good starting point. For example, 80/50 scratch dig for industrial applications and 60/40 scratch dig for commercial applications. Many optics require additional optical coatings, which have their own set of specifications apart from the uncoated substrate. For example, if a coated part has a 60/40 scratch dig, the uncoated substrate usually needs to be on a grade better, or a 40/20 scratch dig in this case, in order to meet final coating spec. As a full-service manufacturer, we at IRD Glass can take a complete coated spec to determine the uncoated specification. But this difference is important to consider if you'll be purchasing uncoated optics to have coated elsewhere. For optical coatings, be sure to indicate the relevant wavelength range of use, as well as the transmission or reflection of maximum or minimum and average. It's also better to be safe than sorry and specify the angle of incidence, especially if it's not just 0 degrees. For filters, specify the cut-on and cut-off transmission profile and tolerances. If you don't have a specification, indicate what you're trying to do and to make sure that the coating meets your real requirements. For anything other than the most standard light sources, you should indicate them in your request to make sure that the coating can function properly. Custom coating designs can be made more or less durable, affecting cost. Be sure to include your durability or environmental requirements. Again, if you don't know what spec to use, let your coder know how the part will be used. Clear aperture applies to coatings as well. If your coating is a pattern, be sure to indicate a location tolerance for the pattern or indicate if location is not important. For parts requiring assembly, it's good to know how the parts will be used. IRD Glass uses a variety of UV cure epoxies and other glues. The optimal glue depends on chemical, thermal, and optical requirements and environmental conditions. For example, glues are not suitable for ultrasonic cleaning. Your custom fabricator will have a variety of ways to clean and package your parts and will generally quote the most cost-effective one. Packing options include paper interleaves, usable cleanroom containers, gel packs, pill holders, and more. Cleaning options include basic residue removal, thorough hand cleaning, and ultrasonic cleaning. Consider how the parts will be used once you receive them. Although particular cleaning and packaging options may be more expensive on the quote, they could save you a lot of time and money on your factory floor by eliminating handling steps. For long-running projects, also consider the environmental and cost savings of reusable or custom-designed packaging. Knowing the development stage of your request can help tailor a quote to your needs. For one-time orders that aren't prototypes, it's best to use an off-the-shelf or catalog part from companies such as Thor Labs and Edmund Optics. If that's not possible, considerable cost savings and faster delivery can be achieved by customizing off-the-shelf products if there's something close to what you need. Avoid specifications that require large batch processes or are difficult to produce. Be open to design modifications to reduce development and small lot costs to reduce no bids. Are you designing a new product and need a small volume prototype? We always recommend customers contact us early in the design process as possible to help design with manufacturability in mind. Let your fabricator know you're still in the design stages. The benefit of using a full-service fabricator like IRD Glass is that our engineers work directly with customers to determine critical function points in the design, cost drivers, and where cost-reducing modifications can be made with minimal performance loss. A quote for a simplified prototype design that tests what you need to test could be a good option before a full-featured product. If you're looking for a new vendor of an existing product, let your fabricator know. Everyone has a standard for lead time, price, and quality, but priorities can be adjusted based on customer preference. If your fabricator knows lead time is number one, they can quote some expedited options that might better fit your needs. It's helpful to know what you like and don't like about your existing suppliers so that targeted care can be made. For example, if it's a quality issue, customized quality control or modified processing steps can be incorporated into the quote. What's the volume potential and ramp schedule? You'd be surprised at the broad range of standard lead times various glass fabricators offer. Get a quote that meets your expectations by providing your own lead time preference and its priority. Oftentimes, small volume production costs have no relationship to larger volumes. Some fabricators can provide a lower cost prototype, but are uncompetitive at larger volumes. Since prototypes are the first stage of production success, it's best to work with someone who can do both. Be sure to RFQ additional volumes to make sure your supplier or product design can meet future volume and cost expectations. There may be additional process development needed to optimize volume manufacturing. Knowing long-term volume production and ramp schedule can help steer your fabricator into process decisions for quote, including custom tooling and fixturing and capital equipment suitable for your growth. At IRD Glass, we're always looking to where our customers need to be over the next 5 years. Your fabricator may not be able to do what you need to do today, but outlooking RFQs can help guide fabricator internal development so that they may have a solution for you in the future. Be aware of specifications that require volume-dominated process costs, especially when making small volume requests. These include double-side versus single-side polishing, coating, complicated tooling, setup, or process, or multi-step productions with different run sizes. What's the application? Application is the driving force in making smart quoting decisions. From material selection to design choices, it's the most important question to answer. Revealing your application or at least general industry in the quote process allows your fabricator to determine if the process, volume, or cost is feasible for your market. A product could be unfeasible because of the overall design or because the particular fabricator is not optimized for that kind of product or volume. It can save both parties time to know if a no bid is the best option. As said throughout this presentation, knowing how a product will be used, your supplier can recommend specific changes to quote to reduce costs without affecting outcome. Even the best designers and RFQs may be missing some information. Knowing the application allows an experienced fabricator to make assumptions that may not be in the original request to avoid potential problems down the line. And finally, application can influence supply chain decisions and information handling, as with defense projects or high-volume commercial applications. The most common flat optics are windows, so I'd like to highlight some cost drivers to consider when placing an RFQ. Slight changes to the design of this window could enable a faster or cheaper quote. Material. Depending on the material type, it could be the primary cost driver. For example, with high-cost materials such as high-quality fused silica or sapphire, reducing the thickness of the window in half could nearly cut the cost of the window in half too. How thick do you really need? Flatness to aspect ratio. Because even glass flexes as it gets thinner, specifying a tight flatness with a large aspect ratio will increase costs. The size of clear aperture. As a window is lapped and polished, the outer portions of a window loses material faster and become thinner. This is called edge roll-off. A clear aperture larger than 80% will drive up costs because edge roll-off needs to be addressed with specialized and often slow processing. Loosening flatness surface quality spec will minimize the cost effect of a large clear aperture. Maximum edge chip. This can be designated as the size of a chip into a part, the total length of a chip, or the number of chips. The smaller and fewer edge chips allowed, the higher the cost, as chipping is inherent and difficult to control. In lieu of edge chips, a bevel spec may be given. Thickness or thinness. As parts become thinner, they become more fragile, harder to fixture, and harder to handle. Very thick parts use more material, which could be a significant cost driver. Large size can be a cost driver both because of increased material costs, as well as less parts per process run. It's also harder to meet various specifications over a larger area. Square shapes are more difficult than rounds. Polishing is done in a circular motion, so a square or rectangle will have some portions of the part seeing slower speeds at the outside than the inside. Roll-off is more severe at the corners of squares and rectangles. On the other hand, if you're using an as-drawn material that does not need lapping or polishing, square shapes are cheaper. It is cheaper to cut into squares with dicing saws or scribing than to core out rounds, which often need custom-sized tooling. So you might say, wow, that's a lot of stuff to include in one RFQ. But like any good relationship, communication is key. The more your fabricator knows about your priorities and goals, the better tailored the quote will be, and the better your chances at a satisfactory purchase. And remember, you're not alone. With over 30 years of experience, we've done a lot of common, unique, amazing, easy, and difficult projects. We've learned a lot along the way, so we can help you make wise decisions where there's uncertainty. Together, we can make your project a success. Thank you all for your time today. That concludes my presentation about a half hour early, so you will have plenty of time to vote today if you haven't already. We'll now open the talk to questions.
Thank you very much, Michelle, for a very thorough overview of RFQ writing. And attendees, at this time, I just want to remind you, if you have any questions, to enter them into the question box to the right of your screen. And we will begin here with our first question. What are the benefits of asking an all-service provider for a complete quote?
Thanks, Robin. There are many benefits to using a complete service provider rather than sending RFQs out to the individual process step manufacturers. For example, if your part has a coating, many coating houses specialize in one particular coating type or another. They're not all cost effective for every coating type. So by using a complete service provider, they can choose a partner that'll be the most cost effective for the particular coating you have. There's also the benefit of having a one-stop shop. You only have to send out one PO. You only have to do one quality check, and it can be a streamlined ordering process. And also, there'd only be one vendor to audit. Having a full service provider also enables the most variety in process. So whatever capabilities are not inherent in-house of the provider, they're usually partners that they work with, at least IRD does, that can provide a complete solution, giving you a more cost-effective and quality product.
Thank you very much. I'm going to wait a couple of seconds here to see if any other questions come in. I'm not seeing any come in right now. So I guess you covered everything so thoroughly, Michelle, that our group today doesn't have any questions. So I am going to go ahead and close the webinar and remind everyone that a recording of the webinar will be available shortly on the Photonics Media website, and that you will receive a link to this recording in a follow-up note tomorrow. And I would like to thank IRD Glass and our speaker, Michelle deCastro, and all of you attendees for participating in today's webinar hosted by Photonics Media. Thank you very much for your time.